Anyway, that's just my two bits.
Yeah, no, I mean, this field is moving so fast. I mean, on the possibilities that it opens up is just outstanding. And my thinking is that well, it just requires a whole new way to think about what we do in terms of thinking about natural systems and dynamics and so forth. So there's a lot of potential here.
Yeah, and I'd like to have a conversation some other time about how this connects to my interest in, the paper I wrote on models and descriptions, using language.
Mhm.
This really opens up that whole conversation. Anyway, we already recording, Leela?
Yes, we are.
Okay. So just want to introduce Professor Hong. He was a student under Sarush and interacted with me, took classes with me, and he's now at University of Oklahoma. Did I get that right, Yang?
You're right.
Yeah, where he's become quite a distinguished member of the faculty, and he has had quite an impact, large number of citations and so on the field. Um, and then Yang saw the paper I wrote as a Nature Reviews uh, opinion on the paper by Carsten Schulz's group on using text generating variational autoencoders to develop equations for models. Um, and I guess he recognized that we were in slightly different ways thinking about the same thing about using, I mean, text generation is what LLMs do. So he contacted me, and that's how I got to know about the work that they're doing. And Song Kun is the student who's a PhD student who's working with him, who has uh, demonstrated some quite remarkable capabilities, I think, very demonstrative of what is possible in the future. So I asked them if they would give this presentation today. Songkon, you could also say a little bit about your background, and whenever you're ready, you can start your presentation. Thank you
Yes,
for being.
thank you so much. It's my honor to be invited here to give a talk. Uh, I will give a quick introduction about my background. And currently, I'm working with Dr. Hong, and I major in hydrology. I will develop some application using large language model with, to apply in the hydrology. Um, I finish my uh, undergraduate and also the master degree in Peking University. Uh, I come here in 2024, start my PhD. So it's my 1.5 year of the PhD. Uh, my master background is remote sensing. So I'm new to the hydrology about 1.5 year. Uh, I would today, I'm really happy to show some work I have done before and currently working with Professor Gupta. I think it's really exciting to show the ability of the large language model can do in hydrology. Yes.
Yeah. Well, let me say a few words. First, I want to thank you, Hoshing and others, invitation. It's quite an honor because I still remember 20 plus years ago, I was taking a class, at Arizona, Tucson, and we're using shadow learning, not deep learning, ANN, applied to a hydrological model, applied to rainfall retrieval from satellite. So that was 20 plus years ago. And later on, I got a little bit conservative when I getting older. But my students, Songkun really pushed me, learn the new AI, especially the agent AI. So since last year, we're working on this. And I'm happy to share some results from our group. Also, we can, discuss and then learn from each others. All right, thank you, everyone. Good to see you virtually.
So go ahead and share your screen then, I think. Did you
Okay.
test it already or not? Yeah.
Yeah, sure. I think I'm ready. Okay, can you see my screen?
Yes, perfect.
Okay. Hello, everyone. Today, my topic is about the world's autonomous hydrology AI agent for hydrological modeling. This is the work last year me and Professor On cooperate. Here's the background. We have a hydrology class last year. I realized like running a hydrological model like CRIST is not easy with a lot of barrier, because for beginners or students without a hydrological background, you need to write in code or process data in ArcGIS, or a lot of skills, and get them together and finally run the hydrological model. And also, you need to have some background to interpret the final results. Otherwise, you don't know how to adjust like some parameters to get better results. I realized like for some people, hydrological model is very powerful. The only thing they need is the final result, maybe from a natural language query says, I want to analyze this flood event in which location and the time period. And with the power, I think with the power of the large language model, nowadays we can translate that to structured data and finally organize coding the tools and do the hydrological modeling and give a report to the user. So I think that's the basic idea I think about. So I try to develop an AI agent to do the hydrological modeling. So what is an AI agent? I just maybe you know, but I just give you a quick introduction about that based on my understanding. So like ChatGPT, those large language model, it's kind of like a brain in a jar. When you're using the chatbot, you usually give it the condition or the background or such as the data type or anything to it. And the more information you're given, it will give you more accurate answers. But that's just the decision you can make for your reference. But for AI agent, I think it's like a brain with hands and eyes. Hence, that means it can use tools, coding functions to do some things like downloading the data, pre-process the data, and also the eyes. That's the perception. I think that's also an interesting part of the AI agent. Like he can interpret the hydrograph and also seeing the basin to find the outlet for you, which can be done using current large language model. So I think it's also kind of shift from telling how to do it, that's the chat box, to doing it for you. That's current agent can do. Yeah. Motivated by the Tesla self-drive, the levels, different levels. In our paper, we try to also divide the AI agent into like 6 levels, from level 0 to level 5. That is from a simple logic to the autonomy of the AI agent. The 0 level means no agent. You should do all the things manual. And for the level 5, that is totally autonomous. Agent do everything for you. You maybe just as a user, as a monitor. I think in current stage, we are kind of in level 4, user as approver, an agent as a task delegate and do a lot of things for you. And finally, you see if the results make sense, you approve and accept, and as a monitor, as an approver. So regarding the hydrologic modeling, that's what I designed for doing the hydrologic model. The input is simple, like can you analyze the July 2025 flood in Kerr County, Texas? At that time when I developed this big flash flood happened. And with this natural language query, I think, can we translate it to hydrologic modeling? And finally, we get a hydrograph, get all the data we need, and generate a report for the user. And for the process, like for this natural language, first we can search and interpret the natural language to a structured data, the specific date, the location, and find a basin. And for user have no background, they maybe say a county, but for the hydrologic unit, we need to find a basin. And tool use download the data, and then per section is for selecting a reasonable outlet. You can give in a large language model the basin graph with the gauges that they choose. And reasoning and reporting, finally get all the results. It can give you a report about this flash flood event. So we have a case study also in this Texas flash flood. Since we have pre-calculated data after running the model, we can see the result fits good. And the agent can write a report. It's a record-breaking flood. I also make a video. Sorry, maybe I need to share my sound. Wait a minute. Yeah, also with the help of the large language model. Let's see.
Hello, everyone. Welcome to Aqua, Automatic Quantification and Unified Agent in Hydrology, built by the Hydros Lab at the University of Oklahoma. It's an AI agent that turns plain language questions into complete hydrologic studies by finding data, configuring models, running simulations, and assembling clear results. And today, I'll walk through a flash flood analysis for Kerr County, Texas. I start on the home screen and launch the analysis. In the console, I select the reasoning model. Here I'm using GPT-4o. And in the prompt box, I type, "There was a flash flood in Kerr County earlier this July. Could you help me analyze this event?" Beneath the prompt are the data options. For precipitation, you can choose MRMS, IMERG, or HRRR. I'll keep the default MRMS. And then I click Run Analysis. As the job begins, Aqua sends the request to the model to parse location, dates, and intent, confirms Kerr County and the Guadalupe River system, and returns a concise location overview and hydrological context. It also surfaces recent news coverage on the July floods in Texas, which I open briefly to verify details. While in the background, the agent downloads the relevant data sets, clips the watershed boundary, and configures the CREST distributed hydrologic model for the July 10th analysis window. With inputs ready, we move into the interactive basin map. The red outline marks the watershed we're studying. Blue markers are USGS gauges, and red markers flag heavily affected hotspots such as Camp Mystic. I can toggle layers for elevation, DM, flow accumulation, and flow direction to understand how the terrain funnels water. Scrolling down to the precipitation views, you see an hourly animation for July 4th and an accumulation map for July 1 to 10. Colors from blue-green to yellow-red show increasing intensity, and the core sits squarely over the basin near Kerrville, exactly the kind of short, intense burst that routes quickly through the steep hill country network and triggers flash flooding. Next comes the hydrograph, produced by automatically setting up and running the CREST model with 2-minute MRMS rainfall. Black points are the USGS observations, and the red curve is the simulation. The timing aligns closely. The simulated peak is higher than observed, and the model reveals minute-scale structure that gauges often smooth, so you can see more detail in how the surge built and receded. To place the event in context, Aqua plots the historical flashiness and frequency. The July 2025 point lands beyond prior observations, so the return period is labeled INF, meaning unprecedented within the available record. Scrolling further reveals the flood inundation view, which summarizes expected depths along the corridor and gives a quick sense of where water likely overtopped. Finally, the summary page collects the essentials, where and what we analyzed: North Fork, Guadalupe, near Hunt, July 1 to 10, what triggered the flood, a short, intense July 4th storm centered on the basin, what the river did, a rapid, record-level spike with good agreement in timing, and how rare it was, unprecedented in the site record, along with takeaways on improving peaks using denser rainfall inputs and local reports. All artifacts, basin maps, precipitation layers and animation, hydrographs, historical distributions, and inundation maps are organized in the results gallery for download, and Aqua also produces a polished PDF report that documents inputs, data sources, figures, metrics, and conclusions, ready to share with colleagues, emergency managers, and community partners. And to emphasize, the only input you need is the single plain language prompt at the beginning. Every other step is handled for you by the agent.
Yeah, I think that's the video showing how the agent works. And today, I would like to talk something interesting. I don't know if you guys have a chance to download the OpenClaw, which is really, really popular recently in China, the media. I see a lot of people, they are trying to install the OpenClaw, which I think kind of the milestone of the AI agent to the public. Although maybe not some new technique, but this is an open source AI agent that can literally do a lot of things for you. I'm very excited about this. Last week, I implemented it and try to analyze it, do some evaluation. We have an AI downscaling product. We want to evaluate its performance. So I create a separate environment and implement this AI agent. I give him all the data, the raw data, and tell it, like, you can do as comprehensive as you can to evaluate this AI downscaling precipitation data to see its performance and its advantage and some disadvantage. And doing now by now, every 5 hours, just do it again. So I literally get, I think it's 2 hours. But anyway, I get a lot of nows. We review that's now what's going on and plan the next move and give me a lot of new findings, I think, compared to previously I did those box plot of the metrics. He also can say, yes, this downscaling advantage appears in this high memory, low flashness basins because he divided into different scenarios and do the evaluation. It really, you can just go to sleep and this AI agent just keep doing this evaluation, writing code and finally give you those report. And I think it's quite exciting about this. And beyond this, beyond automation, that's the previous work. The next challenge is the intelligent calibration AI agent we currently working. The goal is to have a transparent, physics-aware parameter tuning. If you want, you can go to the website I created that yesterday. You can see a lot of figures. The basic idea is like previous calibration, we only focus on one matrix, KGE and SE or anything. We want to optimize one scalar matrix. But as a hydrologist, we think the hydrograph give you a lot of information. Not one matrix can describe all of these things. And the perception of the ability of large language model is quite useful. You can use it, input the hydrograph, and that large language model have a diagnosis and then plan the next move. Like here, I just show a case from the last simulation results. The agent see the problem and have a strategy to have a direction to do the calibration, which is much faster than numerical search because it don't know the physical meaning of the parameters. It cannot see the hydrograph. The only guidance may be only the objective function. So I think this is the power. You can see the power of the large language model can do for the physics-aware parameter tuning. Maybe when we publish this paper, where I can share more of these results. Then I have a summary and the vision. The efficiencies, like with the power of the large language model, those AI agents can do the automation. It can help you with the efficiency in doing modelings. And the next step, we want to, from simple automation to the intelligent physics-aware reasoning, to do the calibration, which requires a lot of intelligence and some vision. This AI, I think, is not a replacement. It handles those tedious things like data coding and formatting, and it do not replace we experts that liberate us to focus on scientific discovery. You don't need to spend days to process the data, that's tedious tasks. And also, like we propose the levels of the AI agent, human in the loop is very important. You should make sure the final result is correct. Then the experience of human is very important. Yeah, I think that's all of my presentation. Thank you. Any questions?
Shankar, this is Praveen Kumar. Could I ask a question?
Yeah, please.
So when we do modeling, we have to make a number of choices. You showed one, which data set to use, but oftentimes the data sets have gaps. They are incomplete. They might be error prone. There are choices of model parameters as to making judgments on different soil types and all that. So how does your agent make those choices, and how do you know it is making the correct choice? And how is it informed in all these regards?
Firstly, yeah, there's a lot of decisions for data using and other things. In the first version of our agent developed, I simplified those like soil type choice. We just use the MIMS data. We have previous calibration parameters that can be used in the simulation. So it's kind of simplified. If you want to make it can be used for all the precipitation or different data, yeah, that requires more, development of this AI agent. And regarding of how do you know it is correct or not? Yeah, that's a really important question, because the hallucination of the large language model, if some step it give you a wrong decision, or just because the information is not enough, the decision is wrong, and maybe finally your result will be totally incorrect. That's why I say in some critical point, human in the loop is very important. You might also want to approve the agent action to verify and it's correct or not. I think that's very important. We cannot guarantee every step is totally correct, but my experience, like if you have the reasonable prompt and give it enough information, nowadays the ability of those advanced large language model can really do a great job. In my using of the agent, the error is decreased. Yeah, but still, I just want to emphasize those human in the loop is quite important at some critical point.
Yeah, so I'm trying to get in a little deeper way into your model, because I think you need to specify some guardrails for these models to work. And the human in the loop, is it that you pre-specify that these are the points of checkpoints, or the agent automatically detects that, yeah, there is some ambiguity and I need to check? In which, if it's the latter, then these checkpoints would be arbitrary. I'm not saying in a negative way. I mean, which will be determined by the problem being solved. But if it's the prior, where you say, okay, at this point you need to check, at this point you need to check. I'm trying to understand how you have implemented so that these modeling outcomes and the associated results are can be claimed to be scientifically valid. I mean, it's an interesting characterization, and I'm all for it. But I'm just trying to understand if you have put in some guardrails or other mechanisms for that human in the loop to act in an agent. For example, if you do the open claw, I mean, that's not, I mean, you can put in some queries in there, but it goes and does whatever it needs to do. There's no guarantee that it's following a scientifically accepted pathway, which we approve.
Uh, uh, for the checkpoint, our agent is kind of simplified. We just defined those important checkpoint because those we just not that complicated. I think the current structure of those agents we can develop maybe can be more critical. He's smart enough to have a planner agent to recognize or when they come up with some medium results, you think this may be not good enough or ambiguous. Need your human decision will stop and ask you. Yeah, but currently the agent we designed last year is not that smart. We still human defined some checkpoint for user to approve. I don't even know if that answers your questions. Or you can say again about.
No, thank you. I mean, first of all, I appreciate what you're doing, and I really like where this is going. These are some things we struggle, so I'm just trying to get some insight if there are other ways of ensuring those challenges. So, no, thank you. I'll let others ask questions.
Thank you.
If I could just sort of comment by building on what Praveen just said. I'm sort of thinking that the agentic process is not static. It has to ultimately have a learning loop built into it. If I were to give the same task to a human being, there's quite a possibility that a human being would also make mistakes. So putting a human
Yes.
in the loop presumes the human knows what they're doing. But typically what we do in human systems is we train our humans. And when they make mistakes, we correct them and then they learn. And so the internal guardrails have to keep updating. And the problem with humans, of course, is that you have an Eric Anderson who does it for the Weather Service for 30 years, and then he retires, and then his knowledge goes away. And hopefully it's embedded in a set of people that he trained. But if he did not somehow encode that information in a written documentation of some kind, which could then be studied and used by other people, that knowledge would be lost. And some of it probably was intuitive and got lost anyway. So clearly there needs to be a learning loop inside this process. And this makes me think a little bit about the process that's in generative adversarial networks. I think, if I'm not mistaken, Songkun, one thing you didn't talk about is that you don't just have a single agent, you have multiple agents,
Yeah.
each of which has a different task, and one proposes something, the other one evaluates it and checks it, and so on. So there's a structure to the agentic process, which is not terribly different from how we build human systems in order to minimize the possibility of errors. You use a lot of redundancy. For example, when they sent rockets to the moon, they had to have three computers do the same calculation. And then they used, the majority vote to see what was the right thing and so on. But I'm intrigued by the idea of generative adversarial networks, because there you train at the same time an actor and you train a critic, and they are in competition with each other. And as the actor gets better, the critic has to get better. And uh, uh, so some of the things that you mentioned, Songkun, as being tedious and being done by the machine instead of a human being, uh, if an expert human being were to do that tedious task, they might notice an anomaly, for example. And
Mm, yeah,
if the agent had not been trained in anomaly detection, it would just follow the algorithm and do what you asked it, but it wouldn't notice that something interesting or weird
going on. Yeah,
was over there. So we even have the distinction between intelligent humans and non-intelligent humans, right? People
yeah,
you just train and they do the job, and then people that you expect to be not just do the job, but go over and beyond that thing. And the thing about generative adversarial networks is that they're constantly, it's kind of like the Turing test. Ultimately, um, you would have to put the agent in one room and you would have to put a human being, an expert, in the other room. And the evaluation task becomes something like a GAN, where you have to be able to distinguish whether it was an intelligent human or whether it was an intelligent agent-based, generating the answer. Anyway, let you respond to that.
yeah.
Yeah,
Yeah,
yeah, I can just add something because as I mentioned at the beginning, I was suspicious about AI. Even my PhD work is about AI in satellite rainfall estimations. Some kind of on the fine line, either how to utilize, but also be suspicious. But last year, when Songkun joined as a PhD, he really pushed me to the limits. Hey, we got to utilize, we got to learn. So I also dig into AI, deep learning, and agent. It's a hell of a ride for almost a year. Yeah, as because I purchased a Tesla, right? I use the uh, FSD for self-driving, and I didn't believe at the beginning, but now I really enjoy it. Every day I go to school, I just let the FSD take me to school and then come home. So it really impacts our life, our work. And go back to the specific AI agent work for hydrology, because I teach hydrology over the last 20 years. It's always repeat, uh, trial and error. So to be specific on when we started AI work for the Songkun presented, what we gave to the AI is just the events information, and also we gave the AI the crest motto documentations, right? The user manuals, which includes a lot of parameter knowledge and the upper lower bound of the parameter value, and how the parameter derive from which physical data. So those are also fed into this AI agent. And I agree with Hoshing. At the beginning, the AI agent just like 2 years old. Then he learned from all the information, from the documentation, from user manual, and there are multiple agents. They double check with each other. They learn from each other, and they're getting better with it. Then they propose a different strategy. And the reason we use the level 4, not level 5, because we still, you know, not trust the agent 100%. So that's why we use the level 4. and the humans in the loop to check each critical point. I just have to say this is still work in progress. It's kind of exciting, but also I'm very cautious about what's next. And so yeah, I'm pretty excited to join this conversation, share and learn from each others. All right.
Yeah. Thank you, Professor Hong. Regarding the experts' knowledge to the AI, I think I have some experience, some detail. Maybe I can talk. There's different strategy from the beginning. Maybe you can train a model with those expert knowledge, but that costs a lot of efforts. Like you just hire a new man and train it from the beginning. And nowadays, we don't want to, discard the base model ability of the understanding of different things. So the technique is kind of like transferred to doing the fine tune with several guidance, fine tune the intelligent large language model to do some expert things like in hydrology, and also reinforcement learning. You can also incorporate your knowledge to the large language model. A more easier way, I think today when I use the OpenClaw, there is a tech called Skill. You can download from the internet. A lot of people, they share their skill. Like when we go to the Claw Hub, here you can see the most star is the self-improving agent. The logic is kind of simple. You just write a prompt to let the agent to have a memory of his failure and the mistake he made and do not make it again. So this is called self-improve. You don't need to change the model itself, but also you just add it to the memory. When agent do something, he need to know this memory and know what he make mistake before. And I think kind of similar when we developing those intelligent calibration agent, we still need to record the memory, even though for those failure iteration, we don't want the agent to make the same mistake again from the history. And then that's the case. And for you guys, if you are interested, I just made with the coding agent to make a public website. You can see the different comparison of our agent calibration and dream calibration to see the difference of the hydrograph and a lot of visualization. And I think today, with the power of agent, you have some picture, you have some idea, you want to do something, and you can, under his guidance, maybe quickly realize your idea, maybe in 1 or 2 days. They save a lot of time. You can focus on some creative ideas. Yeah, that's my thoughts.
Is Praveen still here or did he leave?
No, we just left.
Oh, okay. Because the question I wanted to push back, and I'm curious about what you guys think, is Praveen sort of raised the issue of humans checking the AI, and Songkun also referred to that. But it seems to me at some point you want a closed loop. You also want the AI checking humans. Because the assumption that the human is correct and that the AI is wrong is just an early step in the process, right? True intelligence would have that generative adversarial component to it, where a human might say, oh, you're wrong, but the AI should be able to push back and say, no, I don't agree with you. Let's discuss this. From my perspective, based on the information that I have, which is different from the information you have, what you're proposing may not be the correct answer, or maybe it's somewhere in between. Yeah.
Well, according to how the models are developed in the current landscape, I think we're still a couple of years from that. There are like the agent agreeability and LLM agreeability is still a big problem. It's very hard to make an agent disagree, and provide reasons.
Yeah.
Right. Yeah, I like to echo. Also, I think Hoshin just made the big statement of the future. uh, it's hard to say that to a senior, like me. I'm kind of a senior professor. If I don't believe AI is smarter than me in my field, but we make mistakes. My knowledge is not unlimited. So I think that day is coming. We have to admit AI, they can learn, they can compete, they can reason, and they have even more senses than us. Because one thing I learned from the calibration, we used to just based on the number, right? Time series, whatever. But I think the AI we are using now, it's beyond this, just numbers. They're looking at the hydrograph, looking at the timing to peak, look at everything, look at the you know uh, we call multi beyond the numbers, the figure, the hydrograph,
Multimodal.
yeah, multimodal. Yes, sorry, just had a lunch. Kind of. So that's another power we can explore. But I think one day we have to live with AI. But I still think, collectively we like to have control. And well, this is open question. So as for you guys, young generation to answers, because all right, I just put it right here.
I think Benedict was going to say something, but I just wanted to jump in. A very small example would be once upon a time, I, as a human being, changed gears in the car. And now the car doesn't allow me to change the gears. Well, it does to override it, but now it decides to change gears for me because people have figured out the rules for changing gears, and you don't rely on humans to have to interpret the sound of the engine and all of this stuff in order to make a decision as to when to change gears, right? So as we start to trust the process, we turn over more and more of that capability to the machine, and we start to focus on other aspects of driving the car. Right? Anyway, sorry, Benedict, I think you had something you wanted to raise.
Yeah, just expanding on your idea on like the endpoint should be like an AI that can argue with you truthfully. But I just had today like an instance where it became really clear again to me that the LLMs they don't know, they don't have a concept of truth. They can
Sure.
just pattern match whatever semantic relationship they build from their learning data. So and that counts for, I would suppose, that counts for all developments, also future developments based on this AI modeling paradigm, LLMs. And like, things will only get better if people at OpenAI or whatever come up with a model paradigm that actually provides accountability. I would even go as far as like automation with LLMs is always risky, as long as it is like a probability inference machine, because for every automation process you need accountability, and yeah, so the LLMs can't provide that. Yeah.
Yeah, but is it a technical problem or is it a legal and human problem?
No, it's a technical problem. Like any process, like you need this accountability. The whole process of production is built on that you can count on the outcome.
I'm not sure it's a technical problem. If you take any factory with dangerous equipment, if someone gets trapped in a machine and dies, let's say, it's not the machine's fault. And I think it's not a
Mhm.
technical problem, it's a legal problem, is how do you define the framework around automation and decisions or processes that are not made by humans. I mean, I'm not saying that LLMs are able to fully process a decision pathway and make a decision and give reasons and be liable. I'm not saying, but I'm saying it's not such as a technical problem as it is for OpenAI or other institutions. That is a legal problem. I don't think anyone is ready to see LLMs make decisions for them, but it's not because they can or cannot. It's because they don't want to, I think.
I
Don't
mean,
you think, Antoine, it has to do with the level of risk involved in the particular decision? So your washing machine has for a long time been making decisions for you
Hmm,
on how much soap to use or whatever. And people have
of
shown
course.
that you can use fuzzy logic to land a helicopter which loses a rotor blade, which requires a sort of a fuzzy or probabilistic decision-making process, which was not solved using deterministic logic. Um, so at some point, we sort of turn it over. Uh, Planes are typically put on autopilot and allowed to fly for something, maybe not to land, but
Hmm,
right. And more and more, they're trying to build stuff into cars which allow them to park themselves and so on. But the
hmm.
real issue really becomes when you're talking about accountability, Benedict, it has to do with things where the consequences of the risks are very high, right? And we don't want to turn them over.
yeah, and I would go so far to say like it's framing it as a legal problem is, I think, too narrow because, I mean, of course, you can automatize, people do that, and people generally observe that the outcome without human intervention will be a decrease in quality because you can't get rid of the hallucinations right now. Because LLMs as of now, and I would propose with the current technology paradigm of like, next token prediction, this won't go away. That's and the reason is that it doesn't have a concept of truth. It's not
Right.
event aligned. It doesn't have accountability.
But let me propose a thought experiment. Um, you hire some company to do some job for you. And I'm not going to tell you whether the company is using human beings or it's using LLMs. Okay. That's it's just a thought experiment. Um, if the and then the company buys insurance and so on. If the company does not meet its requirements, you sue them. You either fire them and you don't hire them again, right? The person, and you could do the same with the LLM, or you sue them and there are consequences, and there's monetary things, and so people like a doctor. The doctor typically has medical insurance, malpractice insurance, because if they get sued, and then that's how they're protected, right? So there was that case in Italy where I think it had to do with an earthquake or something like that in Italy, where they tried to sue a bunch of scientists because they did not uh, go on public media and report and warn people or something like that. And they tried to sue the scientists because the scientists were, they're saying you knew that something was going to happen and you didn't report it, and so therefore you're responsible for all these deaths and so on that happen. So you have this interesting uh, ways in which society deals with different kinds of levels of risk. Even trying to struggling with how you deal with accountability and who is accountable and so on.
I'm sorry that I steered this conversation away from the work actually in this general realm where we can only speculate. But coming back to the work, I think it's really great work. And what I especially like is that I was not aware of this Aqua Age paper yet, but I was aware of the conceptual modeling paper, like the second one, the one that came out as a preprint now, and that you showed last. What I especially like about it is that it frames the interpretability problem in a completely new way. Because you can read the reasoning of the model when the model the agent model, and the agent model builds the hydrological model. And I think that's because I'm also very much interested in explainability and interpretability of deep learning hydrological models. Under the question like, okay, like how good is the representation in the model, the hydrological representation in the model, and that just like unlocks a lot of new potential. This method, and I really like that, and I think that's very much worth pursuing.
Can you
Thank you.
post that link in the chat, please, so everybody can get it? Yeah,
The paper, what?
the one that you just referred to. Yeah.
I can ask you questions, Hongkwan?
Yeah, sure.
I'm just having a difficulty understanding the framing of what you do. Let me explain. If I understand correctly, you have a vision model that's improving delineation of basins, right? The vision agent.
Yeah.
Okay. This is what I don't really understand. It seems like you're going towards a direction where you use models and agents to account for data whenever you're uncertain because you don't have that data, but at the same time you expect to have rainfall and hydrologic data to conduct modeling. So I'm not sure whether what you do is addressed towards ungauged basins with minimal information or with places that do have information. Do you see what I'm
do have information. I'm doing that do have information.
So why using a model to delineate basins where you're expected to already have the basin data because you have that data? I'm not sure.
Doing the modeling, you mean why we doing this, but let's have the basin data and the gauge data while doing the hydrological model? Is that what you meaning?
What I mean is, you're expected to have prior hydrological data in order to run the model, right? So assuming that you have data, assuming that the basin is already gauged and known, right? So you would have that delineation data. I don't understand the use for a vision agent to improve that, knowing that you must already be aware of basin. Do you understand where I'm getting at?
The vision agent, right? Yeah. The vision agent design is kind of at first design. I have two function. The first one is kind of seeing the structure of this basin to see its property of this basin. Maybe they give you some information to have an initial guess of the parameters of the hydrological setting. And the second one is when you have a basin, you have a lot of gauges. You want to have a represent of the basin, which is the outlet. That one, you want to choose to represent the whole basin. But choosing an outlet is not, simple task. You can write a code maybe to do that. Usually, maybe you need to see the river network and see this outlet, the gauge within this basin, and determine this is the outlet that we want to finally do an analysis. This gauge represents the whole basin. We want to make this decision, and final report, we can use this gauge as a target. I don't know if that answers your question. The plot, the vision I showed to the agent is kind of a basin, maybe with DEM, and also all the gauges within the basin, and also a buffer, and also the river network. And by seeing that, you can determine which gauge is the outlet that can represent the whole basin.
Okay,
Yeah.
no, thanks. That answers it. I understand a little better. I guess my driving question was more, do you plan to go on places that have very little information, hoping to provide a better assessment with what you have, using LLM agents for that, including vision agents to better determine basins and parameters, or the other way, are you only focusing on known basins with high historical data so you can better drive analysis? But I guess my question was, are you going towards real-time response where you have to make quick decisions and make with the data you have, or more about historical analysis, which is really long time work driving, like looking at historical data to better understand?
Yeah, I think we are now only focus on the later one. Yeah.
Okay.
Sangun, if I
Hi.
can ask a question. Hi.
Please.
Yeah, thanks for this great presentation. I am also wondering about so my understanding is that agents automate tasks, right? But they still rely very heavily on data and the knowledge that they receive. So my question is, do AI agents reduce the importance of high quality data sets, or does data quality become even more important, more critical, because the agent-based modeling workflow will depend on that data?
Yeah, that's a really good question. I think a high quality of data is always very important. Even use the agent, we just automate this process. We are not making the data better and the performance better. So with low quality data, maybe the outcome they just very messy. Like for calibration, you don't know which direction to do that because the initial data is not as good as you think. So I think nowadays the high quality of the data is much more important with the context of the AI agent.
That made me think that then you need an agent to create very high quality data sets before using an agent to perform the actual task, right? Like then you need a set of agents.
We predefine use some very high quality data as the input. Yeah, maybe future we do need to have some agent to check the quality of those data to make sure it's in a high quality input to the hydrological model. Yeah.
I can ask one more question. Could an AI agent learn from those past calibrations and those experiments, and do it across different field sites, and progressively improve the parameter estimation for new data sets, for new watersheds? Or how does it work? Because right now you're only working in one, right? But can you kind of extrapolate that knowledge to other new or uninstrumented watersheds?
Yeah, that's also a really good question. I think that's the final target that if we can use the knowledge that we successfully calibration from the known basin or known gauge to transfer the knowledge to some ungauge and never calibrated, they would solve a lot of problem. That's a big question. And I think that's the future. Now we just have the framework of calibration for the known data, known basin. We have the data. Maybe we can collect those successful experiments, also incorporate with some experts' knowledge to self-train and make the large language model learn the calibration process and see if we can transfer it to some engaged basin. They would be really cool. I think in the future, I would keep working on that. I think it's promising.
One last question would be, is there any thing that agents struggle with, or that you have noticed that agent is not a good tasker?
Oh, yeah. I think first is the safety and hallucination, which means sometimes agent makes mistake. How you handle this mistake, that makes a lot of people unwilling maybe to use those agent, because if in one you have 10 steps, even one step you make mistake, you will ruin your whole process. That will be frustrating. So that's why when develop the agent and using the agent, like in my calibration agent, we have proposal agent and evaluation agent. Like you involve multi-agent, more of them to do the same thing, they would reduce the error generated by the large language model. Yeah, I think the hallucination is kind of a bigger problem of the large language model, but we still have a lot of tech that can handle this. Yeah.
Thanks, Uncle. Great work.
Thank you. Good
By the way,
questions.
Antoine, in response to your question, I don't know if I'd sent this out already. I put a link in the chat. This article called "Unlocking the Power of Time Series Data with Multimodal Models," where they're referring to the fact that if I just give you the data as a data string, and you try to interpret it, that's not the same as if you take that data and first interpret it as a visual image or a plot or some other diagnostic, a different way of looking at the data. And this sort of brings up the representational problem of how do we learn from data, right? So I just thought that was a nice example of how vision complements other forms of analysis. But underlying your question, I think, was a bigger, broader question, which was the evaluation problem. How do you know that you have a good answer?
Yeah, I've been struggling with that for 2 years now, and I have a paper that came back in review for that question.
Okay. So this is what I've been discussing with Song Kun, is that historically, when people built models, they did parameter specification or architecture specification by intuition. There was no automation involved. Well, it was automated through the brain, right? So that's the expert approach. And then about 30 years ago, computers came online, computing became cheap. We started to build more and more complex models. And so we shifted the paradigm to automated optimization using a metric. And one of the points that Song Kun and Yang are making is that metric, and I've tried to make in the past, with diagnostics and so on, is that metric is a compression down to a single number of a very huge, rich amount of information. And so clearly, an information theory should help us assess how much information is in a data set, and it should help us get a sense of the dimensionality of the evaluation problem.
There are really interesting developments in mutual information approximations that can be applied to LLMs. The only problem is, well, there are problems. It's you're stacking approximations on top of approximations. Because if you want to evaluate an LLM, what you need is an extract of these latent representations, so the actual current state. Most API can't even get you those. It's too much compute and data bandwidth overhead. So you can do it with a local model, but you need the juice to be running a huge, like a decent sized model, and still you're still facing that I/O bandwidth problem. So what you can do is what I'm doing right now, but it's approximating on top of approximating. But whenever I generate some content with an LLM, I take those tokens and run them into an embedding model, assuming that my embedding model is trained quite closely with the inner representations of an LLM. And some embedding models allow you to compute the embedding of a whole sentence instead of token by token. And you can use some approximations to compute mutual information between two series of tokens, whether it is vector or matrices. There are a bunch of kernel things. I'm still evaluating how good is that and how it can be applied. But there are a lot of papers on this, not just using this metric. There is a fellow at Stanford. He's a computer science teacher. His name is Edward White Chang, and he's exploring that for a few years now. Dual entropy and other methods for evaluating LLMs and tokens things. I'm following up on his work. Maybe sometime soon I'd like to do a presentation on this, but it's hard to find the time. But I'd like to.
But the point I'm sort of trying to make, Antoine, and I think you're sort of helping to make it for me, is that the evaluation problem is not one of finding the right metric, right?
Yeah.
It's a moving target. Evaluation is always a moving target. That's what I like about the generative adversarial network formulation, where you convert it to a classification problem. Is it real or is it fake? It's a moving target problem. And so at every stage in the evaluation process, you just need to focus on the dominant things that you care about. And as those things get solved, then you change your evaluation, right? I mean, that's how we learn as human beings.
Yeah.
And so this idea of having a fixed metric and a fixed optimization process and a fixed model architecture has to go away eventually, right? I mean, physics has this idea that there's a fixed set of laws of physics and they're invariant and so on. And as human beings, we like that idea. But when we're building models to navigate the world, I think as human beings, very rarely use a fixed model or a fixed evaluation framework.
Yeah, well, to give an example to that, and it's quite funny that Songkyan picked the Texas floods as an example because it's exactly what we used for the last AGO poster and for the article revisions that was submitted just yesterday. And so Songkyan, to give you a bit of context, what I do is I use multiple agents to conduct decision making through discourse. So basically, I come up with a problem, usually hydrological problem. I give it to the agents, I make them debate and come up with human-like decisions. And we benchmarked that against the Texas floods of 2025. So basically, what we did is we took the real-world events up to a certain date and time, and we fed those events to the framework so we could compare the framework's response with what happened in real time. And what we used as a metric was what was debated a lot by the reviewers, and so we had to update that and make some adjustments. But basically, we say that we're pretty happy with the response if everything that happened in real life happened in what was simulated. But if you think about it, even for an LLM, it's a pretty shaky metric. It doesn't have any grounding. It doesn't have any formula, and a lot of people are very uneasy with that. It's very hard to evaluate an LLM, yeah, I think it's a good illustration of what you're trying to say, because that could change a lot depending on the situation. How would you evaluate a different decision? It could be for something that you don't have any real world grounding. You don't have a whole truth to compare against, which was our first scenario. It was a hypothetical Midwest flood scenario. We didn't specify a specific town. We didn't specify a specific time. It was hypothetical. It was just, oh, it's going to rain a lot. It's going to be a big flood. And because you don't have any ground truth to compare against, well, now the metric could be the breadth and the width of the pathway you explore. That was our first metric, but it's very hard to characterize because you use words. Even if you have a representation of those words inside an embedding space and you can somehow measure their information, well, it will change for another scenario. Evaluating LLMs, especially in multi-agent settings, it's extremely hard. It's a very, very hot topic in LLM science today. Yeah.
It's just points. Subjectivity is given a bad rap, right? We went through a period where everything has to be objective, but in reality, everything is subjective.
Of course.
And is context dependent. Yeah.
Of course. Otherwise, it would be so easy to design human decision making with mathematical models. So easy if humans are purely rational. And it's funny because, okay, it is almost not connected at all with what we're discussing, but I recently started Star Trek. And what's fun is they put the opposition between the Vulcans and the Romulans, which are to the paroxysm logical people, no emotion, no feelings. It's a race that distinct from humans because they don't have emotion at all. They use purely rational thinking. And on the other side, there are humans, which is funny because on the other way, it's LLMs and us. LLMs don't have the emotions, they don't think, they're just rational. And the models, the physics, the math, it's exactly the same. And it's the reason why we can't represent human decision making using those tools yet, because we don't make decisions just purely based on rationality. Otherwise, well, that would be different.
I guess there's some people who would argue with you about that. Is a human being different from a machine? Uh, but we certainly have endocrine system and other aspects which don't function quite the same way as a neural system in terms of, you
Yeah,
know, so there's some complexity there which we don't completely quite understand.
yeah.
Uh, yeah. Luis, you've been very quiet.
Yeah, my problem is that I entered late to the meeting, so I was kind of catching up with everything that
Okay.
they said. But related with the last topic, my guess is that the the problem is that, oh, my guess, my opinion is something between. Is that okay? We can model people with machine with models, but the problem is defining how much we can. Because for me, the classic example is I don't know, if you are making decision in a reservoir. So you need to release water. So for sure, this decision is coming from a person that, okay, you shouldn't be able to model a person, but this person is making decision because some weather, some information, something about the past, and maybe a model can use that information to make the same decision. Probably it's not going to be the same, but until some level, humans are making decision based in information. So if we pass this information to a machine or a LAM, they should be learned something or approximation to that. So the problem is how much and how we are moving between these two worlds, that completely rational and completely irrational.
It's an interesting point. I think it connects with what Benedict was saying earlier. But I have to say I agree with what you just said, Luis. But I think, in my opinion, again, I'm gonna repeat the argument I had earlier. It's not about the technicality, can we do it? It's more about, will people be agreeing with that? I think it's more about our opinion on whether AI can take that role than can it.
I have a curious thought. Um, what if you gave a problem to a generative adversarial network where you're training a critic and you're training an actor and a critic, and then you applied an LLM to analyze what the actor is doing and what the critic is doing? Because right now, when you do a generative adversarial network, the decision process, the evaluation process is implicit. It's somehow encoded within the architecture and the weights of the critic. And so you don't really know what the evaluation process or the metric is, except that you know that it's somehow improving itself to become a better and better discriminator. But if you could somehow design a methodology, uh, maybe LLM based, to actually analyze what's going on and to somehow approximate or understand what that discriminator or critic is doing as it competes with the generator, maybe we could get some insight into what you were talking about, Antoine, you know, sort of semi-objectify something which is um, latent or implicitly buried in the learning process of the discriminator. I mean, it's a hard task when you ask people to make decisions in a decision process, which used to happen a long time ago. And then you ask them to report to you the reasoning for their decisions, which is what we ask an LLM to do now. You're never quite sure if the person is accurately reporting. In the case of the LLM, you have an audit trail, but in the case of the human being, you don't have an audit trail, right? So you don't know if they're actually accurately reporting, if they have enough self awareness to tell you whether the reason they made that decision was some some reasoning, logical based thing, or it was some what you called emotional uh, based reason, earlier. And then there was that recent paper where those people uh, um, from Anthropic, where they were studying the internal workings of the LSTM to try to figure out, treat it like you're studying a brain and looking for, you know, brain patterns and so on, like what we're starting to do with human beings now, you know. And then when something happens, this set of neurons gets fired and activated, and when something else happens, this set of fire. The difference between a neural network and a logic-based system is the logic-based system doesn't have neurons that fire. You have decision rules that fire, right? Whereas in a neural network, you have this pattern of weights or pathways that get activated and so on. And there has to be ultimately some relationship between that pattern of activation and something that you could compress down into something like a logical rule. Yeah.
Yeah, it's just a personal take. I don't think he has a lot of academic grounding or anything, but I feel all those. No, I mean, my take on this is I feel like all those discussions have more of a philosophical nature than
Sure.
actual science. Where we will go with the study of the human brain, how close. In my opinion, those are questions that are very hard to answer because we're thinking about them in our own framing of science. We view the universe through all the laws we have written with physics and all that. Um, and in my opinion, it's part of the reason why it's so hard to describe those behaviors that we don't understand because we don't have rules and equations for them yet. But it's even assuming they do, which is more philosophical than scientific, which was the
But
whole
I,
point.
but are you pessimistic about that or optimistic about it?
I'd rather say pessimistic about it.
Okay.
In my opinion, a, a too strict enforcing of conventions and paradigms can have someone's be a little too narrow focused on a problem to but it's just a personal opinion. I've read some philosophical stuff about space travel recently and all that. It's they're just thought experiment to try to broaden the thinking. I was actually sparring with an LLM the other day, trying to come up with something that can't be explained, like a new color or something like that. And I was trying to understand what would be something that would truly be out of the box for humans to understand. I'm just reading some stuff about that, and I just figure it's in history it's been hard for humans not to understand something. We have a strong desire to enforce equations on everything we see around us, which is not bad because it works for a lot of things around us. I just think even those have a limitations,
Sure.
but we would be unwilling to acknowledge that.
Well, Gödel's theorem forces us to acknowledge it, right?
Mhm.
Because within any logical framework, there are limitations.
Mhm.
But what you're making me think of is something related to another thing that Sonkun is doing that he didn't talk about, which is that when his agent generates proposals, um, he forces it to do a kind of a contrastive process. he asks it to generate 8 proposals, and he asks it to generate 8 proposals that might explain what to do that are as different from each other as possible. And that kind of, I thought, relates a little bit to what you just said, which is that there's a tendency for us to all try to start thinking the same direction. Somebody tells you this is the right way to think, right?
Mhm.
And the reason we have artists and why they're valuable to us is artists are kind of like people who say, I'm not going to think that way. I'm going to think a different way, right? And I'm going to explore a different possibility for that thing. And it's like if we become entirely rational and our rationality doesn't incorporate this kind of contrastive uh, exploratory sort of aspect to it, then yes, then I become pessimistic.
Yeah, but yeah, no, totally. This is sort of the not conclusion I reached out, but I was discussing with an LLM about that, and something I've wondered for a very long time actually got broken down by ChatGPT quite fast. But you probably have heard about the perfect crime with an icicle. If you stab someone with an icicle, it melts, and there is no crime weapon. I was so to establish crime. Usually, you need a what is it? Availability and motive and all that stuff. And I was thinking about crime without motive. That would be
Opportunity and motive. Yeah.
exactly, but without motive. And then it led me to ask the philosophical question: do humans ever do anything without motive? And the answer is none. And I was sparing with the NLLM against that. And I was like, why can't we do anything without motive? And it's just not motive. We can do something without motive, but we can't do anything without cause. And it always comes down to causality, to cause and consequence, because this is what rules the universe. So breaking that would be breaking causality. And again, it's a framework we can't visualize. It doesn't exist. In my opinion, some of the answers are behind that. But it's not scientifically, philosophically. It's something that needs to be explored through other ways. Um, so, in all, to summarize, can you commit crime without a motive? Yes, but without a cause, not. And it all comes down to that. What is the difference? And
So you're more of a determinist.
mhm, yeah.
We're getting close to 11:30. Songkun and Yang, uh, I hope you get a sense of why I invited you to talk to this group. It's a very fascinating group. We enjoy our discussions. I hope you will continue to participate.
Right.
And the group, I hope you got a sense of why I thought that the work they were doing would be interesting for us to discuss. Hopefully, we can continue to discuss these ideas and help push the boundaries, develop them some more. As I said at the beginning, I'm highly convinced that we can frame all of this within an information theoretic framework, which is sort of my interest.
Right.
And so that goes beyond Shannon entropy, Shannon information, and algorithmic information to this thing I like to call representational information, which is entirely based on how we construct languages, and language models are based on how we
Right.
construct languages. Right? So
Yeah.
I'm seeing a lot of connections with all these things.
Yeah, absolutely. Well, thank you for invitation, and we'll be happy to stay and come back, continue discussion and learn. Because I don't believe AI is the end of hydrology or scientist. It's but I used to be I changed my attitude. It, you know, you got to keep your enemy closer, right? To utilize your enemy is better. So I mean, there depends on how we treat AIs. There are not everything, not as the end of everything, but and
Sun
also
Tzu's
AI
tug
is a
of
kind
war
of
comes back to us.
yeah. AI is also developed fast. It's moving target. Last year we used ChatGPT 3, 4, now it's what, 5?
Oh, yeah.
Well, so we cannot make any conclusion today, but I think it's part of the journey. We're trying to learn how they can help us. That'll be I'm kind of half 51% optimistic. All right, we'll see what we can do.
Yeah, I have just a tiny question for the people that use. Everyone here are AI engineers, I guess, or most of you guys. And I still can put my hands on why are so much people worried that AI is going to turn on the creators or whatever. Because if you use AI models, you know they're kind of dumb. They're just tools. They do what you ask them, barely.
Yeah. That's also my thought. Yeah, I agree with you. They are just tools. They can do a lot of things, but still, if you don't give it, your final task or something described correctly, it just cannot do as good as you expected.
My own sense is the concern is not this idea of they're going to turn on, which is a very anthropomorphic context, right?
Mhm.
But if you read the comments I sent out in that last email and read that paper about can LLMs be computers, there's the sense in which you can get to a point where algorithms can rewrite their own code, right?
Mhm.
And when they start to rewrite their own code, what can happen then becomes considerably more unpredictable. And I think if there's anything that we have to be concerned about, it's that, it's the unintended consequences that can happen, which are hard for us to anticipate because we think of machines as being things that just do what we tell them. Well, even algorithms that rewrite their own code are just things that we tell them, but they are just doing what we tell them, but they're doing what we tell them in a way that we could not anticipate.
Chaotically.
Yeah.
Mhm.
Yes, I guess humans in general tends to fear and dislike what they don't fully understand. So once this becomes public knowledge and you get more familiar with it, yeah, maybe the perception is start changing.
So we got to go now. Yang and
Towards the
Song Kung,
end.
I apologize for not introducing everybody. But hopefully you guys will come back every 3 weeks and engage in conversation, and you will get to meet and learn who these people are. Very, very amazing bunch of people from all over the world,
Yeah,
and hopefully build some collaborations. Future
absolutely.
interesting.
Thank you.
Sure.
Thank
Thank
you,
you so
Bossy.
much.
Good
All right.
Thank
talk.
you, everyone.
Thanks, guys. Thanks, Leela.
Bye-bye.
Thanks,
Thank you.
Antoine.
Bye.
Mm.
Thank you.
Bye.
Mm.
Bye, Benedict. Bye, Luis.
Bye.